Welcome to another video on false positives and false negatives. We've got three problems here. So the first one, we are going to talk about 2,000 people and whether or not they are allergic to cats. So it tells us that 10% of the population is allergic to cats. So that's 10% of the 2,000, and that tells me that 200 people are allergic to cats. So if we have 2,000 total and 200 of them are allergic to cats, then that means 1,800 are not allergic to cats. We always want to start with our total column first because you've got to have your totals before you can deal with your accuracy rate. Now, this problem tells us that we are 80% accurate. So think about it. If you are allergic to cats, you would expect to test positive. So 200 people are allergic to cats, and you would expect to test positive, and the accuracy rate is 80%. So I'm looking for this spot right here. So 200 times 0.8 gives me 160. So of my 200 people who are allergic to cats, 160 of them will test positive. Well, that means of the 200 test positive, I subtract the 160 who actually do test positive, and that means 40 of them will test negative. Similarly, if you're not allergic to cats, you would expect to test negative, and that is accurate. So you would take your accuracy rate, multiply it, typo, not 200, 1,800 people do not have the allergy, so 80% of that would give me 1,440. So then I need a new color. I would take my 1,800, subtract the 1,440 that tested negative, and that gives me the 360 that test positive. So I have 520 total positive tests, 1,480 total negative tests. Make sure you add those two together to make sure they equal 2,000. It's just an easy way to check to make sure you have your numbers in the right spots. All right, so we have our tables. Now we have probability tables. So when you're reading these, if a person tests positive, that tells you that you are focusing only on the positive box. So my denominator is going to be 520. What is the probability that he or she is allergic to cats? That's the top number. So I want 160 over 520, which gives me a 0.308 probability. Wording is everything with these problems. So now I am doing if a person tests negative, only dealing with the negative. So my denominator is 1,480. What is the probability that she is allergic to cats, he or she? That's again the top number. So 40 divided by 1,480 gives me my 0.027 probability. And this is called a false negative because you tested negatively, but it's wrong. So that's where the false comes into play. If a person is not allergic to cats, that's this line right here. So my denominator is 1,800. What is the probability the test will be negative? Here it is. So 1,440 over 1,800 gives me a 0.80 probability, and that's the accuracy test, right? If you don't have the allergy, you expect to test negative 80% of the time. And letter D, if a person tests positive, okay, so a person tests positive, focusing on the positive, denominator is 520. Probability he or she is not allergic to cats. Well, that's this bottom number. Though 360 over 520 gives me a 0.692. That is a complement to part A, right? Two numbers that add up to be the same, to be whole. All right, number 2. Another problem here with our table. The antivirus software company, blah, 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 1% of all computers are have viruses. The software test is 97% accurate. Complete the table using 80,000 computers. So the total is 80,000. Once again, it says 1% of all computers have a virus. So 1% of the 80,000 computers will have a virus, which is 800. And now, if you've got 80,000 computers and 800 of them have a virus, that means 79,200 of them do not have a virus. Hopefully that makes sense. And once again, if you have a virus, you would expect it to test positive. So this right here is inaccurate. It's accurate, 97% accurate. So 97% of my 800 computers with a virus will test positive, which gives me 776. And if I had 800 total and 776 of them test positive, that means 24 test negative. Now, if your computer does not have a virus, you would expect it to test negative. So 97% of the 79,200 would fall in the you don't have it, so you're negative 76,824. And again, now if I have the 79,200 and I take away the 76,824 that test negative, the rest, which would be 2376, would test positive. So now my totals, 3152 here, 76,848 here. Add them together and make sure they give you 80,000, because if they don't, you jacked up somewhere. And you don't want to jack up. You mess one number up, and every one of these problems is screwed. So make sure you pay attention, you keep your numbers where they're supposed to be, and hopefully you write better than me, because those are some sloppy numbers. All right, so we got ourselves our table. I hope they match. Yep, they did. Okay, so what is the probability that a computer tests positive for a virus? Notice the word if is not present here. No given. This is not a conditional probability. It just says, what's the probability a computer tests positive? Well, this is how many test positive, and that's what we want to know. Out of our total, 80,000. So the probability that we just have a computer that tests positive is 0.039. Almost 4% that we're going to get a positive test. What is the probability that a computer which tested positive? Which tested positive? So we know it tested positive doesn't have a virus. Well, not having a virus is 2376, which gives me 0.754. Next page. If a computer tests negative, focus on the negative. So my denominator is 76,848. Probability it does not have a virus. That's the big number, 76,824. And we get 0.9997. This one I took out 4 places because if you only take it out 3, the probability is 1. And it can't have a probability of 1 because these are not the same. Top and bottom have to be the same if you want to have a probability of 1. All right. And the last one for this problem, probability that a computer which tests negative. Which tests negative? So that focuses me here. 76,848 on the bottom. Actually has a virus. That's my top 24. Super small, 0.0003. Again, we've got to go out 4 decimal places because if you only go 3 decimal places, you're at 0. And it can't be 0 because it's got something. All right, one more. Peanut allergy. As Hazel thinks she may be allergic to eating peanuts, she decides to take a test. The test is 95% accurate. Statistically, 1.6% of the population is allergic to peanuts. My nephew is one of them. Set up a table showing the results of the test if it's administered to 5,000 people. So we've got 5,000 people. And it tells us 1.6% of them are allergic to peanuts. So I take my 5,000 people and I multiply by 1.6%, which is 0.016. That tells me that out of 5,000 people, only 80 of them are allergic to peanuts. So if I take my 5,000 total and I subtract those 80 peanut allergy people, I get 4,920 not allergic to peanuts. Okay, so we now know that our accuracy rate is 95. So if you're allergic to peanuts, you would expect to test positive. So 95% of the 80 gives me 76 people. And if 76 test positive, that means 4 test negative. And if you don't have a peanut allergy, you would expect to test negative. So this is my other 95% times the 4,920, and I have an answer of 4,674. Well, everybody else test positive, and that would be 246. So when we add them up, I get 322 and 4678. All right. Again, add these together. Make sure they equal 5,000, because if they don't, you're in trouble. Your numbers are all going to be off, and then it's going to stink. Okay. So let's answer some questions. How many people tested positive? 322. Right? Just how many people? Total people that tested positive. How many people tested negative? 4,678. Just how many people? Just basic question. How many people with a positive test actually have, now it's how many, this is just a number, but it's a positive test, so we're focusing here. Ooh, that's a gross color. So test is positive. How many actually have the allergy? Well, that's this top number. And get some color here, yo. All right, top number, because they tested positive, but they actually have it, so the answer is just 76, right? How many? Then we get to the probability. If Hazel tests positive, so we're only focusing here on the positive, my denominator is 322, what is the probability she actually has the allergy? So 76 over 322 gives me 0.236. And if she tests positive again here, what is the probability she does not have the allergy? So 246 over my 322, which is the complement of the previous problem, and 0.764. So there are some more examples working through false positives, false negatives.